I am super excited about some of the guests I have coming to this show. Um, I'm going to be bringing on, for example, in January, literally the best data scientist I know. Got a lot of great guests lined up, but I realized that before I have these expert interviews, it's really worth it to dig a little deeper into code because quite frankly, you have to crawl before you can walk. And the reason I started this, one of the reasons, was that I see a lot of sort of mess in machine learning for medicine. I was also encouraged by a colleague at Radiopedia. I also had a lot of experiences that made me do this, but there's a lot of mess in machine learning for medicine. And I'm going to show you a little bit about R. And hopefully, using the R language, you can pick out and find some of that mess and stop bad things from happening. So, we'll get into that this episode. I'll start by showing you an R IDE. There are many possible IDEs you can use with R. IDE stands for Integrated Development Environment. And unfortunately, it's sort of a buzzword that's changed over time in meaning. Decades ago, it meant something else, but these days, when somebody talks about the IDE or Integrated Development Environment for a language, they're really talking about what is essentially a souped up text editor that allows you to code. So what you see that I'm sharing on my screen is RStudio. It is one of many, many possible IDEs for R, but I do recommend that you use RStudio or another popular IDE, because when things go wrong, you can find someone else who's using it and ask them about it. But to give you a quick tour, up here I have an area. I've set up my screen. You can sort of change the visual setup of the screen a little, but I've set up my screen so that I have a place where I can make programs. So, you know, those programs are files, and I'll make a new one, and a console at the bottom, a place where I can look at my environment. So if I wanted to import a data set, I'd see what data sets were there in the environment if I imported more than one, or I could just import one. And a place where I can look at my history. I have a nice tab for plots. I can manage my packages pretty easily. So you can actually write and execute um, one line, two lines, little bits of code in the console. So for example, if I wanted to print, um, make the computer print, this is the console. I could do that down in the console. I don't really need to write an entire script for that. And actually, I can also run single lines of code. So if I wanted to make a line that said print, um, and we're going to put in a string that says, oh, I don't know, I love R programming. I want to just run that line, you know, I can do that too. So I don't have to run every line in the code at once. Let's see. Let's print another string that says RStudio is a good IDE. It actually is, in my opinion. And we'll try running that. Oh, there you go. So we have like a terminal emulator down here. We have a few other things, but this is just one example of an IDE. I actually spend more time in VS Code than here, but this is how I write R programs. And I love R programs, and there's a lot you can do with just R. So what I'm going to do is show you an example of how you can look at machine learning programs. Unfortunately, there's a lot of fraud and bad data management, overfitting, all kinds of problems in machine learning programs in many cases, unfortunately. And as this stuff moves into medicine, we're really in trouble. So I'm going to show you how you can use R, which is very simple programming language, to take a look at data and maybe spot some mistakes in other people's programs, and hopefully, maybe save some lives, because bad programs do actually kill people, believe it or not. The most egregious, horrible example I can think of is Therac 25, where a computer program essentially caused a bunch of patients to get irradiated to death. But there are lots and lots of examples out there of computer programs in medicine that did quite terrible things to patients. Optum being the latest terrible example. Specifically, there was a lot of bias in the program against African-American patients, but we'll get into those kinds of issues next episode. Let's look at something more simple with data in R. So, like I said, there's really a lot of mess in machine learning products for healthcare. I've used an Excel spreadsheet here to create a hypothetical example of the kind of nonsense you see out there. And a lot of healthcare providers actually get sold on this stuff. I mean, I've seen people who should know better at places like the NHS looking at new products and just not knowing how to evaluate them. Some of them don't even really serve a great purpose. So I made a hypothetical scenario based on some of the things I've seen. Let's say there's someone who comes along and they say, I have this awesome, amazing machine learning product. It will give you a patient's age, more or less, and tell you if they're going to die from a holiday suicide by skydiving. So, go ahead, test it. Well, I want to show you how to use R to sort of cut through the nonsense. When you talk about patient's age, you're talking about basically a continuous variable. So they're going to have an actual real age, okay, like I've made on this spreadsheet. And then they're going to have whatever this machine learning algorithm predicts their age to be. And then there's going to be a prediction about whether they're going to have a holiday suicide by skydiving. So I've titled my Excel spreadsheet here, example for YouTube. I've made a very simple example, but I'm going to show you how quickly you can look at data like this in R and figure out whether someone is trying to sell you nonsense. Oh, I almost forgot. We had to turn this into CSV because I don't like Visual Basic for applications. A lot of people would take an Excel and maybe do something in VBA or regular Visual Basic. But people who really, really deal in a lot of data tend to use R or Julia maybe. So I'm just going to take the file and save it as a CSV, which is what it is. I'll show you. And it's a comma separated value kind of file. The Excel thing is a Microsoft thing, but we can save this as a CSV file, comma delineated, save, and then I can take that CSV file and work with it in R, Python, Julia, any of the better statistical programming languages, and that's so I am over here in RStudio now, and I'm gonna start a new file program where I'm gonna take a look at some of this stuff. But first I need to get that CSV into my environment. And before I get it into my environment, I have to figure out where the heck I am. So let's do this. Let's get our working directory down in the console. I'm gonna plug that in. Oh, and I'm in my working directory is actually not the one I want. So I'm gonna set a different working directory. And I'm going to set it to a folder I have called programming. I'll just change this here. Programming. Now, give me a, okay, let's see if this will, okay, so now let's see where my working directory is. I'm a little crazy. I want to just check again. And I've set my working directory to where I put that file. So now I am going to put that file into my environment. So I'll say read CSV, read.csv, and I'm going to tell it to read that file in there, which I called, what did I call it? Like something for YouTube, example for YouTube.csv, I believe. Okay, so example for YouTube.csv. Look, it read into my environment, tells me I have 35 observations of 3 variables. Now, I just work with simple data in my console because I'm, just kind of playing around, but I can write a program up here that will take a look at the data and run whatever commands I want. So the first thing I'd have to do in that program is actually read the data in, like I just did through the console. And then what I could do is I could maybe take a look at the head of the data, meaning the first rows or even all of the data. So let's see. Okay, it actually worked. Wow. So it read in the data and then it showed me the head, the first 5 lines. It shows me like real age, predicted age, Hollisay, suicide by skydiving. And then let's see. Now I am interested to know, kind of just see what is the correlation between real age and the predicted age. But I like to visualize things. So one thing I could do is read the real age into one variable and the predicted age into another, but I'm super lazy and I have limited time here, so I'm just going to use a shortcut and I'm going to instead call it by different names. So let's see, I'm going to graph. We're going to plot, and we're going to use G real age, and we're going to use G predicted age, and just see what happens. So we'll take that line and we're going to run it. I was too lazy to use real variables, but look, okay, so now we've got a plot made over here, not a very pretty one, but I can use some programming to make it prettier, where we've got the predicted age and the real age. Now, if this program actually worked, we'd expect that, when the real age was 70, we'd see 70, and we'd expect that when the real age was 80, we'd see 80. We'd expect essentially a line that, you could do a linear regression kind of analysis on. Instead, we got a bunch of random dots. So if I were looking at this, I might stop right there and say, no, I'm sorry, your machine learning is nonsense. But, salespeople are really clever, and they can probably produce some data set where something looks like maybe there's some hope there. And you can be very sophisticated with R very quickly and pull apart the nonsense if you know what you're doing. But in all truth, some of what is out there in the market is so unsophisticated, it's just plain fraud. It's not even overfitting, it's fraud. So, if you learn literally 20 lines of code in R. You can take some of these products, evaluate them, and realize that it's nonsense. Just by visualizing the variables, one against the other, plotting, just plotting. They give you 500 data points, just plot them. See if there's an actual relationship. It really is often that simple. Let's go back to the data. Now, if you'll notice, I set this up such that we had one thing that our terrible, ridiculous machine learning program produced that was like a continuous variable, and one that was like a binary variable. So the way I set this up, we have something here that should go into basically a linear regression, and something that should go into a logistical regression. So coding something like that in R is ridiculously simple. And I can show you that quite quickly because R is very succinct about statistics. Basically, it's really great when it comes to statistics and image processing. That's what the language is really great for. There are people out there building websites in R. It's not really what it was designed for, although you could do it. R is really great for statistics and image processing, so it's just like a godsend to anyone who wants to do machine learning for, medical imaging. But let's start with baby steps and do something very simple. So, for example, if we look here, I've already tried this, so actually you can see I have read in variables, but I'll show you how I read these things into variables. Like, let's say we want to name them, real age, we'll name it actual age. And then we'll put in that is what it is, okay? And then we'll say predicted age, we'll just call it predicted. And then, like, we want to do a linear regression, so we'll call it linear regression. We could call our linear regression anything. We'll just call it just that. And then the way to do that in R is ln. And we'll say we want to do our variables, which is actual age, tilde, and then predicted age, which we call predicted, and then our data is G, and then we're going to want a summary of our model here. So that model we call linear regression. Okay, so let's read in the variables. Okay. So we just read in a bunch of new values into these variables from the columns. And then let's run a linear regression. It will do just that, but it won't really show us anything about it. And then let's look at a summary of what actually happened in the linear regression. Okay, so down here in the console, I start getting all kinds of stuff. I get residuals, coefficients. I get all kinds of information about my linear regression. And if you want to understand what each of those means, you have to go to a statistics class. This isn't statistics, this is coding. And the point is to code in such a way that we figure out what we need to know and what we need to do. And actually, we figured it out down here in the graph. This
particular set of data wasn't something you should really be running a linear regression on. It's a big waste of time set of data. But I just wanted to show an example of the kind of nonsense floating around out there. And believe me, nonsense is that is floating around out there. So I'm going to bring on really exciting people in the next episodes, people who do not make nonsense, who are, top of their field, and we should all aspire to be like. But I just wanted to give you something different and special, which is an ability to sort of get a sense really quickly from data when you are looking at nonsense. This is sort of one of the superpowers that people who can code have. So I hope you enjoyed this episode, and I look forward to seeing you for another one.